To start section 11.3, we are looking at sector area and arc length. Um, Sector area is pretty straightforward. It's just the fractional measure of a circle. Okay? You don't want a full circle's area, which we know is pi r squared. Instead, we just want a fraction of that circle's entire area. So because we know that there are 360 degrees in a full circle, whatever angle we have here, whatever arc value we have out here, we're going to put that over 360 to get a full circle. So for an example, if we had a 90 degree angle right there, we know that 90 degrees is 1/4 of a full circle, 90 out of 360. So to find this area here, we could take the full circle's area and multiply it by 1/4. So with that in mind, let's take a look at our first example. Find the area of the sector, give the answer in terms of pi, and round it to the nearest hundredth. So we have a circle with a 12-meter radius and a sector with a 131 degree central angle. So for the area of this sector, as we said, the full circle's area, pi r squared, which in this case, radius of 12, so 12 squared. And we're multiplying this by the fraction of the circle that we have. Now, unlike the 90 degree angle that we said in our quick example, 131 degrees isn't a very friendly fraction to work with. So to get this answer in terms of pi, we'll simplify where we can. We know that 12 squared is 144. And we're then multiplying by this fraction here, 131 out of 360. Let's just let the calculator take care of that multiplication. So 144 times 131, and then we'll divide that by 360. We do get a decimal that's easy to work with. It's 52.4. So 52.4 times pi square meters would be our exact answer in terms of pi. To round this to the nearest hundredth, let's multiply that pi out. So we'll take the 52.4, multiply it by pi, and we get an answer 164.62 will be rounded to the nearest hundredth, and once again this will be in square meters for our unit. A couple more practice problems right there. The angles are a little easier to use. You can see a 90 degree angle there in number 3. Let's do number 4 together. In this problem we have a 36 degree arc, which we know is the same as the central angle, at a 16-inch radius. So we'll follow our equation again. Area is equal to pi times the radius squared. And then we have 36 out of 360 degrees. Now, initially this might not look like a very easy fraction to work with, but 36 out of 360, that's 1/10 if we were to reduce that fraction. 16 squared is 256. So at this point right here, we have 256 times 1/10. So when we divide that, we can move the decimal point here. We have 25.6 times pi square inches as our exact answer. And then we can multiply out the pi to get our answer rounded to the nearest hundredth. We get a final answer here of 80.42 square inches as our rounded answer. Let's also take a look at example 5, a little bit of an application problem here. We're told that a windshield wiper blade is 18 inches long, and to the nearest square inch, what is the area that is covered by the blade as it rotates through an angle of 122 degrees? So think about this. We have a wiper right there. It's 18 inches long, and that's going to rotate through an angle that is 122 degrees. Maybe not the best picture here. This might not be a 122 degree angle, but we can go with this to find this sector area. And because this is an application problem, we don't really care about our answer in terms of pi. We can go directly to our rounded answer. So once again, we'll use our equation for area. Pi times the radius of 18 inches squared, and 122 over 360. And because we don't really care about our answer in terms of pi, we could just type all of this in carefully on our calculator, especially careful with that fraction, and we'll multiply these together. And for a rounded answer to the nearest square inch in this case, so our nearest integer value, we are looking at 345 square inches.